All right, we're going to prove that for all n greater than or equal to 1, this sum is less than or equal to 2 minus 1 over n. Okay, so we're going to do a proof by PMI. Okay, so we're going to do our base step. Consider P of 1. Okay, so that's 1 over 1 squared is equal to, of course, 1. And then 2 minus 1 over 1 is, of course, equal to 1. And, right, 1 is less than or equal to 1, so it checks out, right? Let's look at the second case. Consider P of 2. So that's 1 over 1 squared plus 1 over 2 squared, which is a 1 plus 1/4, right? Now let's look at the 2 minus 1 over 2, which is the same thing as 1 plus 1/2. And of course, we know 1 plus 1/4 is less than or equal to 1 plus 1/2. So that works out too. So let's go ahead and look at the induction step. Suppose P of k is true. Thus, right, we have 1 over 1 squared plus 1 over 2 squared plus dot 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 plus 1 over k squared is less than or equal to 2 minus 1 over k. So we're going to assume that, and we're going to consider 1 over 1 squared plus 1 over 2 squared plus dot 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 plus 1 over k squared plus 1 over k plus 1 squared. Now, from our induction step, we know this sum is less than or equal to 2 minus 1 over k. And then, of course, we need to add plus 1 over k plus 1 squared. Now let's go ahead and find a common denominator. So this is equal to 2 minus, so this is going to be k plus 1 squared over k times k plus 1 squared plus k over k times k plus 1 squared. All right, so let's go ahead and look at this guy. So we have 2 minus, so this is going to be k squared plus 2k plus 1 over k times k plus 1 squared plus k over k times k plus 1 squared. Now let's go ahead and distribute that negative. So this is going to be 2 plus negative k squared minus 2k minus 1 over k times k plus 1 squared plus k over k times k plus 1 squared. And now we can combine them, right? So this is going to be equal to 2 plus, so negative k squared, let's see, minus k minus 1 all over k times k plus 1 squared. Okay, so I see I want to factor out a k, so I need to get rid of this negative 1 here, right? Well, I know this will be less than or equal to, actually strictly less than, but I'm going to keep the less than or equal to, 2 plus, so negative k squared minus k minus 1 over k times k plus 1 squared plus 1 over k times k plus 1 squared. And this is positive, right? Because k is a natural number and this is 1 over a positive, so this is positive. So of course, this here, this is the same as this, And then if we add a positive number, this is going to be bigger than this, right? And that way we can get what we want. This is equal to 2 plus, so this is going to be negative k squared minus k, and then this is going to be minus 1 plus 1 over k times k plus 1 squared. The 1's go away, and then I'm going to also factor out the negative, so this is going to be 2 minus k squared plus k, because negative 1 plus 1, that's 0. So it's going to be 2 minus k squared plus k over k times k plus 1 squared. And then we could factor out a k on the top. So this is 2 minus k times k plus 1 over k times k plus 1 squared. And this is exactly what we wanted, right? We have this is equal to 2 minus, so k cancels with k, and k plus 1 over k plus 1 squared, you're left with 1 over k plus 1, which is exactly what we wanted to show, right? We're able to get the sum of the first k plus 1 terms, right, is equal to the formula if you plug in k plus 1. Thus, we have 1 over 1 squared plus 1 over 2 squared plus dot 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 plus 1 over k squared plus 1 over k plus 1 squared is less than or equal to 2 minus 1 over k plus 1. Therefore, by the principle of mathematical induction, we know that for every n, and they said for every n bigger than or equal to 1. So for every natural number n, right? So for every n contained in the positive integers or natural numbers, it doesn't matter, we know 1 over 1 squared plus 1 over 2 squared plus dot 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 plus 1 over n squared is less than or equal to 2 minus 1 over n. And that is our proof.